Hey guys, welcome back to the Rusty Beauty Shop. Today we're going to be working on our Triumph TR4 behind me because we have some issues with it. Oh, wait a minute. Where is the patina? Wow, did somebody paint it overnight? Oh, no. That's our Triumph TR4 over there with the patina. So, did it multiply? Just kidding you. So this is a customer car, and yes, we're gonna be working on this one, not on that one. So this car was brought to me for a little engine tune-up because it does something weird. It runs pretty well, it idles well, it works well on first and second gear, but then when it comes to third and fourth, it just loses power and it just doesn't drive well. So let me warm it up, and then we're gonna go for a quick drive to see what exactly the symptoms are. Actually, before we go for the drive, while she's warming up, I'm gonna check the timing and see what it shows at idle. So I just want to highlight here that the timing at idle doesn't really mean that this is the static timing, because at idle our mechanical advance may already kick in. So that's different than our static timing. We're gonna check the static timing later. So right now I just want to see what it idles at. So I don't know how well you're gonna see it because it's pretty bright here, but it has white marks both sides of the pulley. So I can see that this is very little right now before top dead center. That's probably 2 degrees before top dead center. Again, that's at idle, which means that it's already advanced a little. So that tells me that probably the static timing is gonna be after top dead center, which is wrong. It needs to be, the static should be about 4 degrees before top dead center. But again, this is very individual for every car. This is as per the manual, but the manual tells you that you should set your static timing at 4 degrees before top dead center and then adjust it as required. So this means you have to start driving the car and give it a little bit of advance, a little bit of retard, and see what satisfies you best. But again, right now this is telling me that the timing is a little bit retarded, because even with the mechanical advance already kicking in, we are at pretty much top dead center. But anyways, we're gonna take it for a test drive as it is, and then we're gonna see what we're gonna do next. All right, so it's warmed up now, so let's go for a drive. Second, pretty good, goes up to 4,000 RPM. And now, holy crap. There you go. Can't go more than that. Now I'm full throttle and she's just stuttering. It's weird because in first and second it went up to 4,000 RPM, but in fourth, look, I'm full throttle. Just barely goes above 3,000 RPM. So first thing we're gonna, there you go. Now I can't even accelerate any more than that. She's just stuttering. Okay, let's turn around and try again on the way home. We need to pick up our paper hose because we lost it. Now it does it even in second. Oh wow, are we gonna make it home? Oh wow, that's it for us. Okay, we're gonna cripple her home slowly, and we'll see. All right, we crippled it home, and I guess, I don't know, sounds to me like the timing goes off, but why would it run well initially and then stop running well? So might be fuel related, but anyways, first we're gonna check out the static timing to see where we are with that, and we're gonna go from there. But before we do anything, I want to read the email that the owner sent before he brought the car here, and here's a list of what he has done so far. Set the static timing, check the plug wires, they all measure between 2.8 and 3.2 kilo ohm and are practically brand new. Check the cap and rotor, they look practically brand new. Remove the electronic ignition and replace it with points. Okay, so it has points, not electronic ignition. Check the spark plug gap, replace the coil, check the fuel pump, the bowl, it's clean. Check the inline fuel filter and it is clear. Check the fuel pressure with priming lever into a pan. Thought it may be vapor lock, but this is happening at the start driving before things get really hot. Drain the fuel tank, flushed and filled it and refilled with premium fuel. Check the coolant, check the oil, check the carbs to see if they are balanced. They are pretty close. Check the dashpot oil. Check the pistons to see if they move freely and drop quickly, and they do. He means the pistons inside the carburetors. These are Zenit Stromberg, so he's talking about the air valve. Check the mixture by lifting the piston. Not sure if I got this fully figured out, but the RPM doesn't drop right away, maybe after 3-4 seconds. So that's what has been done so far, and I think again we should start by checking the static timing and see where that is, and maybe adjust it, because I think it's gonna need to be adjusted. Then eventually we're gonna put it on the snap-on Counselor 2 scope, and we will see what that's gonna give us as an idea. But as usual, we're gonna start with the ignition system to make sure that everything is okay there, and then we're gonna move into fuel system. Alright, to check the static timing, we're gonna do the following. I already turned the engine to be at top dead center. This is where the marks are on the pulley. And I don't know if this is the top dead center of first or fourth cylinder, doesn't really matter, because they are both at top dead center when the marks are at the pointer. And it doesn't really matter which cylinder we are checking it on, as long as it is first or fourth. And then we're gonna take a test light, just a regular test light. My test light has positive and negative. Most of the test lights that you get have only one lead, and you connect it to ground and check for power, or you connect the lead to power and check for ground. Here my test light has two, so just to make things simple, I'm just gonna connect the one lead to power so we can check for ground. So now when I touch ground, I have a green light. So we're gonna disconnect this cable that connects the distributor to the negative of the coil. And we're gonna disconnect it from the coil. Oh, that was super loose actually. So that might be our problem. But anyway, we're gonna put our test light in it. And right now we have ground here. Do you see that? So we have ground here, which tells me that the points are closed at top dead center. So we're gonna turn the engine backwards a little bit. Okay. And now we're gonna start turning it and see when the points are gonna open. When they open, our light is gonna come off. There you go. So I'm gonna do that again. I hope you can see. Let me zoom you in. So I'm gonna turn it slowly this time until the light comes off. Right there. So that's where my points are open. And just as expected, we are past top dead center, which tells me that we are retarded. So you know what? First thing I'm gonna do is I'm gonna adjust the timing a little bit. So to adjust the timing, I'm gonna turn the wheel back, but again I'm gonna go past and I'm gonna approach it in the clockwise direction, and I'm gonna put the marks at top dead center. So that's top dead center, and that's assuming that the pulley has been assembled the right way, because sometimes if you assemble the pulley the wrong way, the marks don't correspond. But we're gonna try it like this for now, and if this doesn't work, then maybe we should take our piston stop and make sure that the marks are really corresponding to our true top dead center on the first and sixth cylinder. Oh, sorry, first and fourth. We only have 4 here. Anyway, so now what we're gonna do is, here on the distributor we have this vernier wheel that gives us fine adjustment of the timing. So what we're gonna do is we're gonna make sure to put this vernier wheel somewhere in the middle of its movement, and then we're gonna adjust the timing by moving the distributor, but our wheel is gonna be somewhere in the middle, which is gonna give us the possibility after that, just by turning the wheel here, to do fine adjustment in both directions. So that's, I believe, somewhere in the middle. Now we're gonna loosen the distributor and we're gonna adjust the timing by turning it. And for this test, by the way, you don't need to have the ignition on, only if you have points. If you have electronic ignition, then you're gonna have to have the ignition on. But when you have points, that doesn't really matter. So the distributor is loose. Now let's think. The rotor inside the distributor turns counterclockwise, which means that we have to be pushing the distributor clockwise to simulate the same motion. So we're gonna start turning the distributor clockwise. Again, our timing marks now are at top dead center. If we had marks on the wheel that show 4 degrees, that would be great, but we don't. So we're gonna adjust it at top dead center, and then we're gonna adjust it to 4 degrees by turning the vernier wheel. So again, I'm turning the distributor clockwise until this light goes off. Very slowly. There you go, right there. So now we're gonna tighten it here. And our timing now is set to top dead center. How do we advance it to 4 degrees before top dead center? One full turn of this vernier wheel or knob or whatever you want to call it is equal to 8 degrees. So we just have to turn it half turn. And it has a mark on this side, so I'm just gonna turn it 180 degrees, half a turn, towards me. Because here we have A and R. A stands for advance, R stands for retard. So now, by turning it half a turn, in theory, we advanced it by 4 degrees. And we can check that by turning again backwards the engine. And now we're gonna turn it clockwise towards me until the light comes off. Come on, baby. There you go. Now if we look at the marks, the light came off at a little bit before top dead center, which just by experience I know that pretty much this much is 4 degrees. So I think we are done. We advanced it a little bit, and now I'm gonna connect this back to the coil, and then we're gonna go for another test drive. Before we go for a test drive though, let's check one more time the timing at idle with the strobe light, and you will see that for sure there's a huge difference between static timing and timing at idle. I don't know how well you can see, but we are definitely now at 10, probably 12 degrees before top dead center. So that only shows you that the mechanical advance of the distributor is kicking in at idle. Nope. Okay. Here comes trouble already. That's gonna show us. Well, obviously the timing is not the problem, so before we go ahead with the machine, I'm just gonna take a look quickly at the distributor cap and the points. I know the owner said that he checked them, but I want to check them for myself. Let's see what the gap looks like. Yeah, it looks good. The rotor looks good. No play. Sometimes the metal part has a little bit of play in the plastic, and that affects the things big time. The mechanical advance feels good. Everything seems to be fine. You know what? Let me measure the coil quickly, just to make sure that we are dealing with the right coil. It's not a 6-volt coil, for example. He said that he replaced the coil already, but still, we have to check the things for ourselves. So we're gonna put our multimeter into ohms, and it shows 3.3 ohm, which is exactly what we need for a 12-volt coil. Should we replace this? Yeah, eventually we might replace this spade connector, but let's hook it up to the machine first as it is. Alright, so we hooked her up to the scope, and for those of you who don't know exactly how this machine works, there's a video that you should watch up there if you want to understand what's going on here. I'm just gonna explain everything as if you already know. So we have a primary waveform here in which we can see mainly the dwell. This is where the points close, and that's from here all the way to here is the time when they remain closed. That's called the dwell. So we have about 50 something degrees of dwell, like for 50 something degrees of the crankshaft the points remain closed. Something is going on here, but in this part of the diagram we're gonna examine in the secondary waveform, because this is where things are happening in the high voltage side of the coil. So here I just want to know what's happening during the dwell, since the points close until the points open, and they look pretty good here on number 1 cylinder. Number 2 similar, number 3 it's similar, pretty straight line, and number 4 is similar. What I noticed though, that some cylinders have a longer dwell and some cylinders have shorter dwell. So we can see that in another menu. We can see the dwell bar graph. So here you can see that the dwell varies. This is the dwell in degrees, this is the dwell in percentage. And you can see that number 1 and 4 mostly have longer dwell, and number 1 and 2 have mostly longer dwell, and number 3 and 4 have a shorter dwell. So that only can tell me that maybe the cams on the distributor that are responsible for number 3 and 4 are a little bit worn. That's why they remain closed. That's why the points remain closed for a shorter time, or actually the other way around. Maybe 1 and 2 are worn and they remain closed for a shorter period of time. So that's why it has longer dwell when they are closed. But that's not so critical, I believe, because we are pretty much in the same area, around 50 to 56, 7, 9, something like that. But let's see what's going on in the secondary ignition system, which is the high voltage. So this is the part of the diagram that we want to observe closely. From this spike here to here, that's the time in which we have a spark sustained inside the cylinder. So you can see here that that's cylinder number 4, for example, but you can see that not for every beat we build high voltage in the coil when the points open. We're supposed to have, for every single stroke or every single beat, we need to build the same, pretty much the same amount of voltage inside the coil. But here it looks like not every time we're building it up. This only tells me that the current starts getting drawn right away as it starts getting built up, and it doesn't allow it to build up to 15, 16, 19, which is normal. So let's see for the other cylinders. Number 1, it's pretty much the same thing. Number 2, same thing. Number 3 just goes up and down all the time, and number 4 goes up and down. So this tells me that we have a short or close to short somewhere in the secondary system. But there's another menu here. Let me just check the temperature. Okay, we're good. There's another menu here which is KV histograph. So here, let me clear it. Here the scope shows us 256 consecutive firings of this particular cylinder, and it tells us how much KV we built for each firing. And you see here, this is cylinder number 4. Most of the time we don't build any KV. Some of the times it goes high to 15, 16, but most of the times it is down. Let's do the same for number 1. Number 1 misses some strokes, but most of the time it is up. Number 2, did we already observe number 2? I think we did, yeah. Number 3, it's all over the place, and number 4 is all over the place as well. But number 2 and number 1 actually, and number 2 are totally different. So you know what? Number 1 is the best, even though it has some misses, but number 2 is the worst, I think. So what we're gonna do is we want to see if that is the cables. Maybe the high voltage cables are not good, or the spark plugs might be short, might have internal shortage, and start drawing the current right as it starts getting built. So first what we're gonna do is we're gonna switch 1 and 2 the cables, the high voltage cables, and we're gonna see if the picture here switches as well. So the cables have been marked by the owner. He put 1, 2, 3 and 4 zip ties, but we're gonna mess up his order just for a test. I'm assuming it's the spark plugs, but we're gonna test the cables first. So we're gonna take this one from number 2, we're gonna move it to number 1. So the fact that it is specific for cylinder, the same thing doesn't happen to all cylinders. All cylinders are different. This is telling me that it is after the distributor. It's not the points, it's not the condenser, it's not the coil, it's not even this wire here that we have suspicions about. It is something in the secondary, which is after the coil. But maybe not, we will see. So number 1 and number 2 are switched. Let's see how the picture is gonna change now. Okay, we still have here the old picture from number 1 and number 2. So let's see how they're gonna change now when I start the car. Maybe we're gonna run it halfway and we're gonna turn it off so we can compare them. Hold on. Oops, my machine was disconnected. Okay. So it's pretty much the same thing for number 1. So this is the old and this is the new. Let me turn it off now. So this is how it was before. This is my error here, but this is after. So it is pretty much the same thing. Let's see for number 2. Same thing. Before my screw up and after. So obviously the cables are okay. So my only suspicion is the spark plugs. Let me take them out. Okay, the spark plugs are super fouled, but that's because we were idling the car for a long time. It's possible that they got fouled because of that, but we're gonna change them anyway. So they are Champion L87YC. we're gonna change them. I don't have new ones, but I'm gonna change them with a good used set. And if that makes a change, we're gonna go ahead and buy new spark plugs. All right, so I put some NGKs and let's see what the machine is gonna show now. I switched the cables back to 1 is 1 and 2 is 2 because they are marked for the owner, so we don't mess his marks up. So let's see. Okay. That's much better, even though we still have not much better. Pretty much the same thing. Huh. It's better than before, but not great. Still not great. Number 2. So that's number 2. Let's see number 1. Number 1 looks better too. But we know that 3 and 4 were all over the place. So let's see them. Oh, that's also better. Misses every once in a while, but again, these are not brand new spark plugs. These are used. Let's see the waveform menu, secondary waveform. Okay, that looks much better already here, right? Still misses every once in a while though. Number 1, 2, 3, the spark line goes crazy. Let me see what this meant. I've seen that before. Indicates high secondary resistance. This is the waveform that we're observing here every once in a while, you see? That's number 3. But again, I'm pretty sure this is from the spark plug. Well, I think what we should do is we should take it for a test drive, and if it drives well enough, we should go to the store and buy spark plugs. New ones, install the new ones and continue from there. Another TR4 to the rescue. We went to the store and we bought 8 actually. Their entire stock of BPR 6HSs, NGK. That's what they had. This one drives better. Have a new set of spark plugs installed, and I don't want to hook it up to the scope yet, because if we idle it, we might foul the spark plugs, because if it is running rich or something with the fuel system is not okay, it's going to foul the spark plugs again, and we're not going to be able to tell on the road how it performs. So as it is with new spark plugs, I'm just going to start it and go for a test drive, and then if it runs well, we can hook it up to the scope as well and check. I have the feeling, okay, every time I come out of here it sounds promising, and then very soon it goes away. Hook her up to the machine again, still does the same thing. So the secondary wave form looks much better. Well, actually now, again, it's missing. Something just doesn't allow it to build enough kV. Or maybe the fuel is way too rich and just combusts way too early. I don't know. Let's see the histograph. Okay, so cylinder number 4 actually goes pretty well. Well, it misfires every once in a while. Number 2 is misfiring more often. 3, 1, look at that. Hold on, we have another menu here. So if we go to kV bar graph, this tells you in each particular moment how much each cylinder. So the minimum registered per cylinder is this, the maximum is this. But I'm gonna disconnect one and we will see how far it's gonna build, because if we remove the spark plug now, there's nothing to use the voltage that builds up in the coil. So we're gonna see how much kV we're gonna build up there. All right, I disconnected number 3 now, and you can see what's happening here. As soon as the points open, we build up to, what is this, like 40 kV, and then because there's no spark, if we don't have a spark line, the voltage just starts dissipating and disappears into nothing until the points close again and start building up again. Which, as soon as we disconnect it, we have another spike here and it dissipates. So the coil is capable of building the kV that we need. Okay, it's the next morning, and yesterday I even tried with a different distributor cap and wires, and it was still doing the same thing. So I don't know, but today, since the engine is cold and there's something else on this car that needs to be done, and that's to torque the head, and of course after that we're gonna have to adjust the valves. So that's also gonna give me the opportunity to check if all the valves work properly, because I don't know, maybe it's a low compression due to valve issues, or maybe even the cam timing is wrong. So I'm gonna adjust the valves, and I'm gonna check also the camshaft timing by checking whether the two valves on the first cylinder overlap at top dead center. You know, that's different method. Maybe I'm gonna show it to you, but first of all, I'm gonna torque the head and I'm gonna adjust the valves. Okay, the head is torqued. For that I needed to remove the rocker shaft, of course, so I can reach these studs on this side. And just a quick reminder that if you're doing that, if you're removing the rocker shaft, make sure that the push rods are not stuck to the rockers. Like, they don't get stuck, but the oil creates a vacuum inside, and sometimes when you lift the rockers, that lifts the push rod with it, and the push rod sometimes lifts also the tappet inside. And on TR4, surprisingly, it's possible that the tappet comes out of its bore and falls in between the head and the bore inside the block. You know what I mean? There's enough room for the tappet to come out and fall perpendicularly. Don't ask me how I know. It happened to me before, and I had to actually remove the next one next to it. I soldered some wires on an LED bulb and I shoved it down there so I can see a little bit from here, from the other side, and then with a magnet I played with it, and I was finally like, I spent 2 hours for 2 tappets to put them back in their bore so I can push them down with the push rod. So the easy solution to that is just make sure that the push rods are not stuck to the rockers, and when you're lifting the rocker shaft, you're not lifting any of the push rods. Anyways, the head is torqued, so now I'm gonna put back the rocker shaft and I'm gonna adjust the valves. Just took a quick look at the springs to see if any of them is broken or anything, if we have a loose valve, and we don't, so I don't think there's any issue with the valves. Alright, so we're gonna check the timing right now, the camshaft timing. And first of all, I wanted to make sure that the mark on the pulley is corresponding to top dead center. So that's why I put a piston stop right here. That I have a piston stop that I made, but this one somebody donated to me. His name is Sandy. And with this piston stop, now the engine, I can turn it, hold on, I can turn it only so much, like it reaches here, and now the piston hits this piston stop. and it hits it. If we look at the pulley, it hits the piston stop like 1 inch before the pointer. So we're not looking at this diagonal line here, we're looking at the line that goes back and forth, straight back and forth. So this is pretty much 1 inch from the center of the mark to the pointer. And now if I turn it the other way, the engine, I keep turning slowly. There you go. So now the piston hit the stop again, and now the mark is literally 1 inch away from the pointer again on the other side. So that tells me that the true top dead center is exactly at the mark. So the mark is confirmed, and now what I'm gonna do is I'm gonna remove the piston stop, and I'm gonna make sure that the two valves, the intake and the exhaust, are equally open when the mark is at top dead center. We're gonna do that with a dial gauge. And for those of you who don't know, this is what the piston stop looks like. So this thread here bolts straight into the spark plug place, and then this bolts inside. You can adjust it and make it stop the piston at some point. So this is a factory one, I guess, but this is one that I made long time ago. I literally broke a spark plug and I drilled inside and tapped hose for this bolt, so it does the same thing. So this bolts into the spark plug hole, and then the bolt goes in and out as far as you want it to go. So I'm not going to explain way too much about how the timing and how the valves work based on like when the valves open and the valves closed. I'm just going to tell you that at top dead center, but not the firing stroke, the next top dead center, when the crankshaft rotates once and goes to the piston goes to top dead center again, that's when the two valves need to be equally open. The exhaust is on its way to be closed, but it's still not fully closed, and the intake already starts to open, and it's a little bit open. So in theory we can say that they have equal amount of opening, but one is almost closed, one is just starting to open. So at this point now we are at top dead center here, but this is our firing stroke for our first cylinder, because this is where the valves have a gap. So this is the power stroke. So we're gonna rotate the engine one turn, the crankshaft I should say, one turn, until we have the mark again at top dead center, like this. And now our sixth cylinder is at firing stroke, and our first cylinder is at that point where the two valves need to be equally open. So let's see how we can measure now whether they are equally open or not. Okay, so this is this would be great if we have two gauges that we can put one on the intake and one on the exhaust, but this type of gauge I only have one. So we're gonna do them one by one, and we're gonna compare the two measurements. So right now I set up the gauge on the exhaust valve in such a way that when the valve is fully closed, it shows 0. And like we said, the exhaust valve on this point is on its way to be closed, but it is not fully closed. And we are at top dead center, by the way. So now if I continue turning the engine, the valve is gonna go already closed completely now. You see, it shows 0, and doesn't matter how much I turn the engine, it just stays there until it goes to the next time it needs to start opening. So I'm gonna turn the engine back now. We're gonna go past the mark, and we're gonna approach it clockwise. So when we go to the mark right there, now we are at the center of the mark. Now our gauge shows counting from 0 this way, because if we continue turning, it's gonna go up to 0, right? So now we are at 15, 19 and a half thou. Let's reconfirm that. If we continue turning the engine now my way, is it gonna go to 0? Yes. it went to 0. So 19.5 thou. Now we're gonna do the same with the intake. For that we're gonna turn the engine back again, like quite a bit, which is gonna mean that the valve is fully closed. Now eventually at some point it's gonna start opening, and at top dead center we'll see if it opened 19.5 thou or some other number. So now I'm gonna move the gauge to the intake and zero it in this position where I know that the valve is closed. I even have a little play on the rocker now because of the position of the camshaft. Okay, so the gauge is positioned here, it's 0, and we are way before top dead center, right? So now if we start turning the engine, initially it shouldn't move the gauge, and when it starts opening, we're gonna be just before top dead center, right there, started opening, and we are almost at top dead center now. So I'm just gonna continue until we are at the mark. Wow, it went one turn, so that's 37, right? 36.5 thou. So they are not very equal when the crankshaft is at top dead center. So now I have to figure out whether it is advanced or retarded. It's better to be a little bit advanced than to be retarded. It's very close, but I think it is a little bit off. Okay, it took me a minute to figure that out. But yes, it is advanced, which is a good thing. It is advanced because this is the intake, right? So it just started to open, and at top dead center, it is already open a little bit more than what the exhaust is. This means that it started opening a little bit earlier, which again, it's a good thing that it is not retarded. So many times when you do the timing on the camshaft, you can't go to the exact position, but it is advanced by degree or 2 or sometimes even 3. It is better because the chain eventually, the timing chain eventually starts stretching with the mileage on the engine, and because of the backlash that the slack creates, now your engine becomes a little bit retarded and it actually goes to the position that you want it to be. So this means that the cam timing on this engine is probably degree or 2 advanced, which is normal, which is a good thing. So with that confirmed, I'm gonna assemble the valve cover again, and we're gonna continue with our endeavors here. All right, so what I did was, instead of taking out the points, you can see she's still running like crap. So instead of taking out the points and condenser and replacing those, I just took another distributor that I had handy and replaced the whole distributor, and it still does the exact same thing. So it's not the distributor, it's not anything inside the distributor. So next I'm gonna replace the coil as well, just to double check, you know, to make sure that we have a good coil, even though the owner said that he replaced the coil before. But I will replace it again with one that I know that for sure is working. Okay, I changed the ignition coil, it ran the same way, so we eliminated that as a problem as well. So now everything here is the setup that belongs to the car. So the distributor, the coil, the cables, the cap, everything is from this car. So now we know that the problem is not in the ignition system. Timing is good, even the cam timing is good. So we're gonna have to turn our attention into the fuel system. And first thing I'm gonna do is I'm gonna remove the fuel filter, because it feels like once you start driving, initially it drives well, and then after 30 seconds or so, the problem occurs. So maybe she's starving for fuel, and for that, we're gonna check first, we're gonna remove the fuel filter. I'll see if I have another one, but if not, we're gonna just bypass it for now. We're just gonna put a straight pipe there for the test. And then we're gonna go and start checking the carburetors. All right, so I replaced the fuel filter, nothing changed. So of course, next step was to start digging into the carbs. And I took the covers off to check the diaphragms. I took out the air pumps, and there was oil in the dashboards. The diaphragms look good. They're assembled the right way, because sometimes you see these two holes underneath. They have to be on the throttle side, and that's how these are assembled properly. So this is the rear carb, this is the front carb. We're not gonna mix them. The needles look good. So far, so good. These are not adjustable needles, these are adjustable jets. So I went to look at the jets, and this one, the rear one, looks much lower than the front one. And I looked at the needles again to make sure that they are the same, and they are. So that's telling me that one carburetor was running rich and the other one was running less rich, I should say. Not lean, because we don't know, but one was richer, one was leaner. So that's one thing that I see. But the other thing that I found out, since I started taking apart the linkage also, because I want to take the carburetors out and check the float balls and make sure that the needle opens and closes and the float is adjusted the proper way. And I noticed something pretty serious. Look at that. This is the throttle shaft. It has so much play, and this one is the same on this side. I have the feeling that there's absolutely no seal there. So you know, these have seals. They're not like the SUs. The SUs use the SUs have bushings there, and they have to be replaced. These ones use a seal there, so obviously somebody rebuilt them, because look, these gaskets look new, but they took out the seals and never put them back. I'm pretty sure the seal is missing. Anyway, that's a serious problem, and I'm sure that it was, if it wasn't the only problem, it was at least a big contribution to what was happening with the car. So I'm gonna take out the carbs now, and I'm gonna continue stripping them. All right, the carburetor is out, and it looks like early ones, I didn't know that, but the early ones don't have seals. What do they rely on? I have no idea. I have to look that up, but it looks like they don't use seals. But anyway, there's a play here, a huge amount of play, but it's only in the horizontal direction. Up and down, it barely has any play. But the funny part is that if I open the throttle, now the play is in the vertical direction and not in the horizontal. So this is telling me that the shaft is worn, and when I look closely right here, I can actually see how much the shaft is worn. Yeah, anyways, let me look this up and see what normally seals here. I don't think it's just the shaft against the body of the carburetor. I don't think so. There must be a bushing or something. It's a little bit worn. Okay, both sides. You know what? I'm gonna clean it, even though we have to replace it. But I'm gonna clean the shaft, and I'm gonna put it here to see. So I cleaned it a little bit, and you can clearly see now the worn part. But when we try now with this part here that is not worn apparently, it still has a lot of play there. Oh, it's not a lot. Actually, it feels pretty good. What about this side? And this side as well. Okay, so I went on the Moss Motors website, and they sell bushes for here. Oops, we still have fuel in it. They sell bushings for here, but this means that the body needs to be drilled and rimmed, and bush can be installed. So that sounds like a Dr. Carburetor job. That eventually might contract him for that. but actually it feels pretty good here. So I'll see if I have maybe another set of shafts. All right, so we took the float bow out too, and there's nothing wrong with the floats. This is the jet, by the way. That's how you adjust the height of the jet from here. This can come out, but this is the body of the jet, I guess, and this is the jet inside. So this is actually in two pieces. The jet is spring loaded, and the more you tighten this, the higher the jet goes. Now we are upside down, so that's why I'm pointing down, but that screw here pushes the jet towards the needle, and if you loosen this screw, the spring pushes the jet back towards the screw and makes the mixture richer. So here we have a measurement that needs to be, I believe it was about 15 millimeters, and here I know we have a gasket, so we're gonna take the gasket in consideration, but that's almost 20 millimeters here. But again, I never know where to measure this, because in this end it's also, well, I guess everywhere is the same. So it looks like the float is adjusted a little bit too low, and that might cause it to close a little bit earlier before the float bow is full. So I'm gonna bend this tab here a little bit to allow the float to go a little bit higher, which means to reduce that 20 millimeters to 15. That's gonna allow the float bow to fill up a little bit more. Of course, if it goes too high, it's gonna make it overflow, so we have to be careful. Okay, I assembled this one without the throttle shaft, of course, just sitting there, but I wanted to make sure that everything is in one piece other than the throttle shaft. So we're gonna take it out after, when we decide what we're gonna do with it. And I opened the other one, and you can see the other one is already, the float is much lower. I mean, lower now, but when you flip it upside down, it's higher, so it's gonna give us higher level. So you see 14. So I'm gonna assemble this one too, and I'm gonna take the throttle shaft. I haven't taken it out yet, but I'm gonna take this one out as well, and then we're gonna see. We're gonna have to buy new throttle shaft, at least, if not new bushings, to rebush this. Okay, so I put together the bottom of the carburetor, the whole carburetor actually, and we know that everything else is good, but the shaft, I just took out the shaft, and it is the exact same thing. I think even worse. You see this step here and this step here, it's just like the other one. The good news is that if we take this shaft and we put it here, again, just the part that is not worn, this feels nice and solid here. There's no play here. So we're gonna order 2 new shafts, we're gonna replace them. I don't think we need to rebush it. All right, it's 2 weeks later, and we are finally back on this beautiful TR4A that had issues with the carburetors. We finally have 2 new throttle shafts that I ordered from Joe Curto, but it took 2 weeks for them to arrive. So anyways, let's assemble them. So the carburetors, I put them here before so I don't lose them. So now we can take them together with the shafts, and we're gonna go assemble them on the bench. Well, actually my bench is overcrowded, so we're gonna work on this little table here. So first of all, we're gonna have to shorten these a little bit because they come a little bit longer, so you can use them for different types of carburetors. I believe the ones on the TR6 Zenith Strombergs are a little bit longer. Anyway, they are exactly the same, and these two, the old ones, are also exactly the same. I wanted to make sure that we don't mess them up, so they are exactly 5 inches. I measured them, 5/16 diameter by 5 inches length. Of course, we need to cut the side without threads. But as you can see here, the threads on the new shafts are a little bit longer, and this flattened part is a little bit longer too. So we need to align the flattened part and then shorten them. So if we cut them to 5 inches, that would be a mistake. We need to cut them to 5 1/4, I believe. So good thing we noticed that. I was thinking to cut them on the lathe, but I don't want to grab them here with the chuck of the lathe, so I'm just gonna cut them with an air tool here. Okay, so I'm gonna go clean this burr on the bench grinder and then we're gonna assemble it. Okay, so I don't remember which one is which, but I know that they are opposite to each other. Both levers are on the outside, and this is where one lever goes. This is the idle screw, so this needs to be this way and this needs to be this way because the idle screw is on this side on this one. Okay, so this one goes here, and when the choke opens, pushes it open too. For this one we don't have the part that is interacting with the choke because here we don't have this ball, right? So this is for this carb and this is for this carb with the other shaft. So we're gonna leave this one alone for now. And we're gonna assemble this one. So we're gonna put the lever later. First let's put the throttle plate because we don't want to put this backwards. We don't know whether it goes like this or like this in this hole. So first we're gonna do the throttle plate. So again it goes from this side. Nice and tight. So this is the countersink part, so that's how the plate is gonna go. Okay, we need to make sure that the throttle plate closes perfectly. So now we're gonna put these screws, and if you pay attention here, they have a little cut on the back. So this is in order to prevent them from loosening. So we're gonna tighten them with the throttle fully closed. Okay. Still opening and closing perfectly. And now we're gonna reverse it and we're gonna try to open this just a smidge so it tightens. Actually that works pretty well. With a screwdriver, there you go. Perfect. I hope we don't need to take them out now. And this one is assembled. Nice and tight. The other one is the exact opposite. It goes from this side, right? So now we can take it apart and do the same thing. When I take it apart, I'm gonna measure again to make sure that the new shaft is cut to the exact length. Actually, I can cut it like that. Okay, so it's all assembled, everything is connected, the two carburetors are hooked up together here with the shaft for the throttle and the shaft for the choke, and the choke and the linkage is connected here, so we're ready to start it. So that's all I'm gonna do tonight because it is almost getting dark outside and it's cold and the cars blocking me outside of the garage, so I don't want to move everything. And to do this properly, we're gonna have to warm it up to check the airflow, because now that we disconnected it here, they might not be even anymore, so we have to sync the airflow again and all that. And for that it needs time, and we need time for that. So I'm gonna resist the urge to take it for a test drive today but at least I'm gonna see if she's gonna start. Oh. Okay, that's enough for today because I don't want to get the garage too smoky. So yeah, you have to be patient until tomorrow so we can do a little bit of adjustment and take her for a test drive. So sleep fast so the time comes sooner. You see, I told you time flies. You slept really fast, so it is the next day. So we started her, we warmed her up. I checked the airflow of both carburetors. Apparently it didn't change. I had to return this screw a little bit. The one that follows the cam on the choke, because I couldn't return the idle. It was idling at 1500 and I couldn't return it from the idle screw because this screw was running on the cam already. So the cam now, it has actually additional spring here that somebody put. So the cam is returned all the way, and I backed the screw up just enough so it doesn't touch when the car is idling. Only when the choke is applied, that's when this screw needs to touch the cam. So then I was able to return the idling screws, and now she's idling at about 900 RPM, which is great and sounds good. So before we put the air cleaners on, you know what's next, right? Let's go for a test drive. Okay, we're actually almost out of fuel from all that testing, idling and all that. So we're going to the gas station. And yes, I put a jug of fuel in my trunk. Now she drives great. Wow, it's cold. An exhaust, but that's another story. All right, so obviously that solved the problem that was causing this beautiful car not to run properly. So anyways, we put gas. I drove it for like 5 kilometers and I came back and I checked the spark plugs now and they're too clean. You see, they're very, very clean. Only number 4 has a little bit of color, but only on one side. On the other side is also clean. But anyway, obviously it is running too lean, so we're gonna turn the front carb 1 turn and the rear one half a turn, because it looks like these are a little bit better, and we're gonna make them a little bit richer than what they are, and we're gonna go for another test drive and we're gonna check again the spark plugs, and we're gonna keep doing that until we're happy with the color. So almost done. Okay, so I actually did 2 test drives because it still showed a little bit of lean condition when I did the first test drive. So I made them a little bit more rich, and I actually put the air cleaners and this tube just to make sure that everything is in the same conditions as when the car drives normally. And then I went for another test drive, and this time it shows much better color on the rear carb. The front one, the second cylinder looks great. The first cylinder is still a little bit lean, so I'm gonna turn it half a turn more, and that's where we're gonna leave it. And that's gonna be everything for this car. So I'm hoping that you enjoyed one more troubleshooting video. This time at least we know what went wrong, because in the last one on the TR6, remember, we couldn't figure out what was wrong with this distributor. Many people suggested many different things. Well, these are all things that make sense, but that distributor didn't make any sense. Anyways, we solved the problem there without going to the bottom of it. Here we at least went to the bottom of the problem and we figured it out. So I hope you enjoyed it, and that's everything for today. Thanks for watching, commenting, subscribing and sharing, and supporting the channel, which is very important. It's really appreciated, and I'll see you in the next one. Bye.